Hello everyone, I hope you all are doing well. So today we'll start with the very first chapter of JEE Mains, which is sets and relations. Now this chapter is the most basic chapter of JEE Mains. This is there for you to build your concepts of how generally sets and relations work in different types of functions or different types of geometries or any other things. So this chapter is quite important for you. Now, there might be no direct questions from this chapter. If there are a very few direct questions. However, still this is a very important chapter because this helps you build your concepts. So that from the next chapter onwards, whenever there are a lot of concepts used which are going to be related to this chapter. So it is important for you to study it properly. So in this chapter, let us look at the subtopics that we are going to be covering. First, we'll look at a brief intro of what sets and all are. Then we'll look at types of sets. Then we'll look at how sets generally work and what are their uses and how we can use them in our different questions. Then we'll look at Cartesian product, and these are all relation properties. So without further ado, let's start. Now, first of all, what is a set? A set is defined as a well-defined and distinct collection of objects. So in mathematical terms, if X is a member of set A, so we denote it as X belongs to A. So we write it as X belongs to A. Now, for example, A is a set. Generally, sets are represented by elements inside the set and they are enclosed in a curly bracket. So let's say if this is my set A set belongs from 1, 2 and 3. So this is my A set. So I represent it by denoting it the elements inside curly brackets. And now let's say if I say that X is a member of A, that means how am I going to write it? X belongs to A. Now if X belongs to A, that means X value can either be 1 or it can be 2 or it can be 3. So that means X is belonging to this set. So X can take either of any values of that set. Similarly, instead of numbers, you can represent any other things, be it any adjectives, be it any colors or any other English words. Now, one more thing that you need to understand. Let's say what if I have a set which does not have any element in it. So I can still represent it as A belongs to this set. Now it does not have any element in it. So we simply represent it by curly brackets. There is no element inside it. Also, this is sometimes represented as phi. So keep this in mind. Now generally there are two types of representing any sets. One being the roster form and the other one known as the set builder form. Now what is a roster form? In which all the elements are represented explicitly. That means 1, 2 and 3. Now let's say if I was to represent this 1, 2 and 3 in terms of words, how am I going to do it? It can be written as A equals to X given that X is a natural number less than 4. That means if I was to write this set down, first of all, it is written in this format. X is a natural number less than 4. So I can write it down in this way also. That means any natural number less than 4 would be in this set. So natural number, where does it start from? It starts from 1, 2 and 3. Now again 4 wouldn't be included because it says a natural number less than 4. It does not say natural number less than or equal to 4. So keep this in mind as well. This is the set builder form, and generally whenever questions are asked in JEE mains, they give you the set builder form. So understand this term correctly. Now ordered pair. Ordered pair is simply a pair of elements where the order in which I write my numbers matters. So for example, if I have A comma B, that means I cannot say that this would be equal to B comma A. because it is an ordered pair. So A comma B and B comma A are different entities. So if I have to, let's say, count the number of ordered pairs, so I will consider A comma B as 1 and B comma A as 1. So these two are considered differently. Similarly, the examples have been given here. Two ordered pairs A comma B and C comma D are said to be equal if and only if A is equals to C and B is equals to D. So if ordered pairs are equal, that means their corresponding position elements should be same. And also one more thing, let's say if in my pairs, what do I have? I have both the elements same. Now again, if both the elements are same, even if I reverse it, it is going to be the same thing. Then, so that is why we considered if I have elements same in my pair, they are considered as ordered pairs. Unordered pair is simply the reverse of ordered pair. Here A is comma B and B comma A mean the same thing. They are considered as one entity only. Now let's talk about the types of sets that we have in total. First of all, we have a cardinal number. Again, this is not a particular type of set, but this is used to determine the amount of elements inside your set. So cardinal number or cardinality of a set is the number of distinct elements in the set. That means if A is equals to 2, 4, 3, then what is my cardinal number for this set? It is going to be 3. And generally, how are cardinal numbers represented? We represent it as with the letter n. So n of A is equals to 3. So this is how we represent a cardinal number. Now talking about an empty set, as we discussed earlier, a set which has no elements in it, it is also known as a null set. So an empty set is denoted by either curly brackets with no elements in it or simply by a phi sign. You can see an example here, the set of integers between 5 and 6. Of course, between 5 and 6 there are no integers, there are only real values. So D is equals to x belongs to 5 less than x less than 6 and x is an integer. So of course there are going to be no elements in this set. So we call it an empty set. Singleton set. A singleton set is a set that contains exactly one element. So there is only one element inside a singleton set. That means if I was to represent its cardinal number for a singleton set, my n of any set A would always be equal to 1. And for an empty set, my n of any set A would always be equal to 0. Now talking about a finite set, a set which has a finite or countable number of elements in it, it is known as a finite set. Infinite set which has unlimited number of elements. So for example, I is equals to 1, 2, 3, 4 and it goes up till infinity. Or if I was to represent this in set builder form, I can say J is equals to X. X is a real number greater than 0. So we know there are infinite real numbers greater than 0. So it becomes an infinite set. Universal set. A universal set is a set that contains all possible elements of that particular topic that we are discussing. So for example, if I say I have a set A which belongs to X, where it has elements X, which belongs to X is a natural number. So that means I am going to have this set as 1, 2, 3 and this would go up till infinity, right? So this is known as a universal set. That means it has contained all the elements of the thing that we are discussing. Now let's say if I would have said A is equals to X, where X belongs to a natural number which is greater than 4, then it wouldn't have been a universal set, because I'm talking about numbers which are greater than 4. So 1, 2, 3, 4 are getting left out, right? So it does not become a universal set. So keep this in mind. Universal set could be anything. Again, it should take into account all the elements of the topic or all the discussion that we are going in. Equal sets, and not forgetting, universal set is generally represented by a U, or it is sometimes also represented by a mu sign as well. Equal sets. Now two sets are said to be equal if all the elements are same. So first of all, for equal sets, what we can say is n of A would be equal to n of B. That means the number of elements in A should be equal to number of elements in B, and all elements of A should be equal to all elements of B. So keep this thing in mind. Two sets are said to be equal if they contain exactly the same elements. Now A, for example, A is equal to 1 to 3 and B is equal to 3 to 1. So these two sets are considered to be equal. Even if their order is different, we still consider it to be equal sets. Now let's say if in the question they mention that the order signifies or the order is mattering, then we cannot say that A is equals to B. So keep these few things in mind. Equivalent sets. Now do not confuse yourself with equivalent sets and equal sets. Equivalent sets are sets which has the same number of elements. However, in equal sets we have the same number of elements and each and every element is also same. In equivalent sets we only have NA is equals to NB. There is no other condition that each and every element is same. So from here, one conclusion that you can make from here is that each and every equal set would be an equivalent set. However, the reverse is not the same. So let me write it down for you. All equal sets are equivalent sets. However, all equivalent sets would not be equal sets, because you can have the same number of elements, but the elements might be different. So however, the vice versa does not imply. So keep this thing in mind. Now talking about subset. Now for any set to be a subset, first of all we take two sets into consideration. Let's say I have a set B and I have a set A. So A, generally if we are talking about subsets, it is represented by this. It is represented in this way. A is a subset of B when we know that all elements of set A somehow or the other belong to set B. Now set B can be a very big set. However, A is just a portion of that set B. Then we call it a subset. So if I go by the definition, set A is called a subset of another set B if all elements of set A are also set elements of set B. However, the reverse is not true. All elements of B are not these does not belong in all the elements of A. Every element in A must also be in B for A to be considered as a subset of B. Now sometimes what happens is these two sets can be equal. Let's say A we have 1, 2, 3, 4 and in B we have 1, 2, 3, 4. So still we can consider A is a subset of B, right? So that time what happens is when these two are equal, that time we represent our set A and B in this format. And let's say if they are not equal to B, that time we call A is a proper subset of B and it is denoted in this format. So let us take an example here. Let's say A is 1 and 2 and B is 1, 2, 3, 4. So here I can say A is a subset of B, because every element of A belongs to every element of B. Now C 3, 4, this will also be considered a subset of B. But what happens is, let's say if I have A as 1, 2, 3, 4, then what can I say? Then A is a proper subset of B. Sorry, if I have all elements of A as all elements of B, then these two becomes equal sets, and A is not considered a proper subset of B. So keep this thing in mind. Here there has been a printing mistake, but it's not, but it's a proper subset of, because C and B are not equal. Now talking about superset. Superset is simply the reversal of subset. So let's say if A is a subset of B, then we can say B is a superset of A, and we represent it in this format, simply the reversal. So if B is equal to 1, 2, 3, 4, B is called as a superset of A because A has just 1 and 2 elements, and every element of A belongs to every element of B. So here you can write down two sentences about these two sets. A is a subset of B and B is a superset of A. Now power sets. Power set of a set is a set of all possible subsets of A. So let's say I have my A as 1, 2, 3 and 4. So what are the subsets that are possible? Subsets are possible. One is 0. There is no element in this set. This is also considered to be a subset of A. I can have 1. I can have 2, 3, 4, and similarly this can continue on forever. I have 1, 2, then I have 1, 3, and this can continue. Then I take 3 elements, 1, 2, 3. Now I can take 4 as well, then 2, 3, 4, and arranging them accordingly. This can go on, and finally I have 1, 2, 3, 4, all the elements. Now these are all considered to be the subsets of A, right? So from here what I can say is, if I take the set of all these subsets, if now I represent this in a set, then I call this as a power set of A. So this can be represented as P of A. P of A. So this is how power sets are represented. Now before we move into a few more things, let me give you a few more information about subsets. These are important points that you need to remember. That every set is a subset of itself. Is a subset of itself. Because each and every set, if I take the same set and consider it to be denoted by another variable, I can say that these two are subsets or supersets of each other, right? Because every element of one set would belong to every element of the other set. So we can say every set is a subset of itself. Phi is a subset of every set. Of every set. Because phi means that we do not have any elements in the set. If there are no elements in the set, we can still say that whatever is present in this set can be a part of the other set, right? Where we have elements. So phi also becomes a subset of every set. Now let's say if I have number of elements in my set as m, then how many subsets are possible for that entire set? So total subsets possible would be equal to 2 to the power m. So keep this formula in mind. Let's say if I have, as we were taking this 4 element set as example. So here we had n of a is equals to 4. That means total number of subsets that would be possible would be 2 to the power 4, which is nothing but 16. So that means you can have 16 values inside your power set. So here you would have 1 is 5, 1, 2, 3, 4, 1, 2, 1, 3. Similarly, you would have 1, 4. Then you could have 2, 3, 2, 4. Then you could have 3, 4. So this would continue on until each and every element has been taken till you reach the end where you have this subset equal to the set that you are talking about. This number would be equal to 16 or 2 to the power n. Now if I was to talk about the proper subsets, let's say if I have n of a again is equals to m, then number of proper subsets would be 2 to the power m minus 1, because in proper subset we do not consider the set which is equal to our set. So number of proper subsets would be equal to 2 to the power m minus 1. So in proper subsets what we do is, again, let's say again in this example only, let's say if I take all these subsets 5, 1, 2, 3, 4 up till the end, the only thing is if I do not consider this one which is equal, if I do not consider this one, then I can say all these are proper subsets of my set A. So that means in proper subset I am only excluding the one which is not equal to my given set. So keep these things in mind. Now talking about power set again, the set of all the subsets is known as my power set. So what would be my number of elements in a power set? It would be 2 to the power m simply, where m is considered to be the number of elements in A. So keep this thing in mind.